All right. This is the Algebra 1 Unit 2 Lesson 5 video. And this lesson is introducing kind of the basic idea of algebra. And it's kind of this foundational thing that you really need to understand before you go much further in the course, because it's kind of everything that we do in algebra is built on the ideas presented in this lesson. So I'm going to run through examples of each type of algebraic property and kind of talk through the big ideas of what's going on in this lesson. So the big idea in this lesson is that we can imagine the two sides of an equal sign as being perfectly a kind of balanced scale. And they use this example in the lesson. You've got these two things and they're balanced, right? And so these two things are equal. If I remove something from this, it's going to suddenly go up because it's unbalanced. And so we want to keep things the same. So if I take away something from one side, I need to take away something from the other side in order to keep things balanced. So this idea of balance is the most important thing that we do in algebra. So for instance, just as a basic example, if I say that x plus 3 equals 8, I'm saying that everything over here is the same as everything over here. There is a balance between the two sides of the equation. Let me erase that. So the reason I drew this dashed line is because this is kind of how you need to think about it. You need to realize that anything you do to one side of the equation has to be done to the other, because if these things are balanced and I take away something from this side, I need to take away something from this side to make up for that. Or if I add something, I need to add something. Or if I divide this into parts and I divide this into parts, I have to do the same to both sides. So no matter what you do in algebra, you always do to one side of the equation what you've done to the other. And remember, the goal here is to find out what x equals, right? We want to know x equals what? And so the goal is to do things to this equation so that the x is all by itself in the equation and everything else is moved to the other side. And later, as you go into algebra, there will be other types of equations that you solve slightly differently. But in general, the idea is always to understand what does x equal. And so, or whatever variable you're looking at. So if I'm looking at this and I see that x plus 3 equals 8, and I know I have to keep these equations balanced, and I want to get rid of this plus 3 so that x will be by itself. If I want to get rid of this plus 3, I'm going to do the opposite thing. Okay, so this idea of doing the opposite is also one of these most important ideas in algebra. So we're always going to do the opposite to x. So in this case, because it's x plus 3, I'm going to minus 3 from this side. And because I did that to this side of the equation and I want to keep everything balanced, I have to also take away 3 from the other side. So if I take away 3 from this side, I got to take away 3 from this side. So I'm doing the opposite and I'm doing the same thing to both sides. When I do that, this cancels each other out. And that's what I want. That's the goal of doing minus 3, is to get rid of that plus 3. And then over here, I just work this out. 8 minus 3 is 5. And so I see that x equals 5. And so that's basically the main idea of algebra. So let's look at another example where instead of x plus 3, for instance, I have x minus 8 equals 4. Okay, again, I know I want to keep my equation balanced across that equal sign. I know that I want to get x equals at the very end. And so in order to do that, I need to get rid of everything that's with the x and move it to the other side. And to do that, I know I have to do plus 8, because this was minus 8. So I do the opposite, plus 8, and I do plus 8 to this side as well. Again, I have to do to one side what I do to the other. So minus 8 plus 8, that cancels out, leaving me with x equals 4 plus 8 is 12. Again, in algebra, you're always doing the opposite, and you're doing the thing that to one side that you did to the other. Okay, so far we've seen what happens when you have minus or plus. We've seen what happens when you have a minus. Well, what if I have the following? 3x equals 15. Now, this is important because you need to remember that when you see 3x, it means 3 times x, and we'll get to that in a second. I'm going to go and draw my dashed line to show that this is where the equation is balanced. And I know I want to get to x equals. So how do I get there? Well, I need to get rid of this 3. But since 3 is being multiplied times x, I can't add 3 or subtract 3 to get rid of it. I have to do the opposite. So in the same way that plus and minus are opposites each other, multiplication and division are opposites of each other as well. So I'm going to divide by 3. And if I divide by 3 to one side, I have to divide by 3 to the other side. So these are going to cancel each other out. 3 divided by 3 is 1. So I'm left with 1x or just x. We don't have to write the 1. 15 divided by 3 is 5. And that is the final answer. So you can see we do the opposite. And let's do one last example so we can look at all 4 operations. Let's say I have x divided by 4 equals 2. So x divided by 4 equals 2. Again, we said earlier that multiplication and division are opposite. Right now, x is being divided by 4. I'll go and draw my dashed line to show that we are going to balance our equation across this line. But I'm going to multiply, because multiplication is the opposite of division, by 4. Multiply by 4 there. I'm going to multiply by 4 here. These are going to cancel, leaving me with x equals 2 times 4 is 8. So what I want you to take away from this is, in all of these examples, 2 main concepts. 1, you always do to one side of the equation what you did to the other. And do the opposite of whatever it is that's happening to x. So if it's x plus 3, you do minus 3. If it's x minus 8, you do plus 8. If it's 3 times x, you do divided by 3. If it's x divided by 4, you do times 4. And these things can begin to grow where there's more than one thing happening at a time. So let's look at that right here. So let's say I have 2x plus 7 equals 15. Okay, so now there's more complexity. There are now 2 different things happening over here on the x side. I'm going to go and draw my dashed line. And I know I want to get x by itself. That's the goal, to get x by itself. And so we need to decide how we're going to go about doing this. So there are 2 ways you could start. You could start by dealing with the 2. You can start by dealing with the 7. But I want to talk about what I think the best way to do this, and that is to follow the order of operations in reverse order. So if you remember, order of operations is PEMDAS. And we want to go in the opposite direction when we solve. And that should make sense, because when we were working things out, we went from P to S. And now we're kind of doing the opposite. We're undoing everything. So if we're undoing everything, we want to go in the opposite direction. So we're going to start with the 7. And the way we're going to do is we're going to subtract 7. And if I do that to this side of the equation, I must also subtract 7 from this side of the equation. This 7 minus 7 cancels out, and I get 2x equals 15 minus 7 is 8. Grab another color here. 2x equals 8. Well, this is 2 times x, and if I'm multiplying, then in order to get rid of it, I divide, and I get those cancel out. Gives me 8x equals 8 divided by 2, which is 4, and that is the solution to that. So that's what it looks like when there's multiple steps. So let's jump over and look at the questions from the lesson and see if there's any other examples I need to do. So you got vocabulary at the top, 1, 2, 3, 4, all the way. Then we get to number 5. Number 5, we did examples like this. It's x plus a number. So you need to get rid of the 1 somehow. Number 6, I will do an example of that here in a minute. So it looks like I need to do a couple examples of some multi-step problems. So let me do a few more examples of those, and then we'll talk about what to do next. So I'm actually going to make this in a new drawing. Let's go over here. Drawing. Okay. So they've got some problems here where you have something like this. 3 over 3x over 5 equals, let's see, say 6. All right. So this is an example of a problem where we have a number being multiplied and divided by x. And they kind of suggest doing this in a particular method, and that is to recognize that this is the same as 3/5 x equals 6. And if you do think of it that way, then you can simply multiply by what's called the reciprocal of 3/5. So a reciprocal, it's an important math word, you've probably heard it before, means to take a fraction and to switch the top and the bottom. And when we do that, 5 over 3, and we multiply those together, the 5 cancel out, the 3's cancel out, leaving me with x. And then all I have to do on the other side is do 6 times 5, which is 30, over 3 equals 10, and so x equals 10 would be the solution. So this is what they call multiplying by the reciprocal. And so that's any time you have a fraction that is like the following. Let me look at the lesson to make sure I'm covering everything we need to cover here. Yep. Okay. Yeah. So let me do one more example. All right. So let's say I have 2/7 x equals 4. Okay. 2/7 x equals 4. We're going to multiply by the reciprocal because this is a fraction, and the reciprocal of that fraction is 7 over 2. That cancels those out, leaving me with x equals 4 times 7. 4 times 7 is 28, divided by 2 is 14, and so I would get x equals 14 as my answer. And so that's any time you have a reciprocal like you see in number 9, number 6. Then the rest of these are just multi-step problems, and I'll just work through a few more examples of those. These would be problems where you have some kind of bunch of negatives, you have multiple things being done to x, and so you have to basically unravel this. So remember, we're going to go in PEMDAS reverse. So we're going to start with addition and subtraction. We have plus 9. We're going to draw our little dividing line over here. And we see that if we subtract 9 from both sides, I get negative 2x. These cancel each other out, equals negative 9 minus 3. You can use your calculator if you need to, but that's negative 12. Now, don't let these negatives scare you. We still have negative 2 times x. So we're going to divide by negative 2. Those cancel, leaving me with x equals, and then negative 12 divided by negative 2. Those negatives are going to cancel each other out, leaving me with 12 divided by 2. Again, use your calculator if you need to, is 6. Again, multiple steps, do PEMDAS in reverse. A lot of these are very similar. Not really much to say about them. Yep, those are all very similar. Number 15 is a little weird. I'll actually do this one for you. I don't really like the way that they introduce this or the way that they show this. But let's say x minus negative 7 divided by 3. Okay. X minus negative 7 divided by 3 equals 8. Okay. This is kind of a weird problem. I'm not really sure why they're throwing this in there, but it is a little bit of a confusing thing. But what you need to understand here, this is kind of a key idea, is that if you subtract a negative, it's just the same as saying x plus 7 divided by 3 equals 8. Now, this is an exception to kind of the PEMDAS rule, and what you need to see is that this is together in parentheses because it's one unit. I can't go subtracting 7 yet. So actually, the first step in this problem is to do the division of the 3. So we're going to multiply both sides by 3. Those are going to cancel, leaving me with x plus 7 equals 24. And now we do the opposite again. We do the opposite to the plus 7. So it's going to be minus 7. X equals, this cancels out, 24 minus 7 is 17. And that's the answer. So I will, hopefully that'll be enough to get you through. You remember you can always check your answers by plugging in the number into the x in the equation to see if it works out correctly. But please reach out to me if you have questions about this. And I will be posting a lesson 6 video tomorrow, and then we'll be testing next week.